Hey, welcome back to Math with Patrick. It's March 17th. We have problem number 76 from the Daily Epsilon calendar, and we're going to solve it together. We need to find the sum of the roots of this thing right here. Okay, sum. This just means to add two things together, and a root is going to be some number that I stick in this spot for x, such that the whole thing right there turns into a 0. That's just the definition of what a root is. So if I can find a number to stick in for x, and I get a 0 out of multiplying and adding these two things, then I have found a root. Well, let's try it out. So I'll just write it horizontally. So I'm just rewriting exactly what I see, but in one line instead of two. And the first thing I notice is that if I plug in x equals 7, it doesn't really even matter what the other factor is here. 7 minus 7 is just going to be 0, and so I don't really care what is in those spots for this x minus 5 and x minus 15. Like, sure, this will be a 2 and this will be a negative 8, but it doesn't really matter. I get a 0 plus a 0, that's just 0. So when x is 7, I get 0. Thus, x equals 7 is one of the roots. Now, it'll be a little bit harder to find the other one. How about I notice that my first term here and my second term here have a similar factor in them, the x minus 7. So I can factor out the x minus 7. And let's see what I leave behind. From the first term, I leave behind an x minus 5. And from the second term, I leave behind an x minus 15. And I'm doing a plus sign here because there's a plus sign here. And so you could imagine if I redistributed this factor at the start to both of these terms, I would just get back to where I started originally. And the reason why I'm doing some factoring here is that a factored form of a polynomial like this one is going to be probably the most useful form to write it in if you want to find roots. So let's simplify this right side. I still have an x minus 7 on the left, but it looks like I have x plus x, so 2x, and then negative 5 plus negative 15, so that's a minus 20. I guess I could factor a 2 out of this because these are both even numbers. So overall, the completely factored form would be 2 times x minus 7 times x minus 10. Again, you could imagine redistributing that 2 into both of these numbers, and I would get back to 2x minus 20. So again, finding roots. I need to make sure that I know when this thing happens to be 0, and I already found out that when x is 7, I produce a 0 out of this. And this other factor, this x minus 10, shows me that when x is 10, I get another 0. So 2 roots, 7 and 10. I need to find the sum of the roots. I see no other factors. Like there's no x plus 3 over here. There's nothing else that's going to tell me that there's another number out there that would produce yet another 0. I believe 7 and 10 are my only roots. So adding these together, I get the number 17. That matches today's date, and we are all done. I guess if you wanted another strategy, you probably could fully distribute everything first, then collect up your like terms, and then factor it yourself. Though I feel like, why do that when you already have this x minus 7 as a factor already? So there's a train of thought where when you want to solve polynomials, you expand everything and then try to do something with it. But I figured, well, there's some strategies we could do here to be a bit more efficient. So there's the answer. There's a 17. We are all done today. Thanks for solving this with me, and I'll see you tomorrow. All right.